All right. So the first sheet we're going to work on is the one that says investigation. And normally I would have you guys actually kind of work through this on your own and see what you come up with. But because I'm not there, I'm going to walk through this one with you as well as the other sheet. And I realized that we didn't really get a chance to cover excuse me, any questions that you had from your homework. There will be a video of the homework worked out for you guys posted probably after class at some point, and you guys will be able to go into Google Classroom and view that. So if you had any homework questions, it'll be there for you. All right, the investigation. So we're given a set of parametric equations, x equals negative 3t plus 6, y equals 4t minus 8. The idea here is that we want to follow a sequence of questions here, which is going to kind of lead us into what's going to happen at the bottom here, which is a way to lead this into something else. You'll see what I mean. So the first thing we want to do is determine the slope of the line which is described by this set of parametric equations. Remember, this is going to be some form of a line because each one of these things is going to affect the x and affect the y, and if you plotted all the points just like you did on the homework, then you would see that it would be a linear function. So the easiest thing to do, hopefully you guys figured it out, was that this piece right here and this piece right here was your change of y and your change of x. And a slope, of course, is the change of y over the change of x. So our slope in this case should just be the change of y, which is 4, over the change of x, negative 3, because in the parametric equations the 4 out in front of the t represented how many units up and down this equation went, and then the negative 3 out in front of the x represented how much left and right the equation went. So the slope there is 4 over negative 3, or negative 4/3. Now, there are several other ways to come up with these, which is why it was an investigation. I am just showing you what I think is the easiest. If you've come up with a different way, then that's fantastic. Number 2, determine the time that an object moving according to these equations would be at the y-intercept. Well, hopefully we all know that if something is at the y-intercept, that means the x value would be 0. So we can actually make the x value in this upper equation equal to 0 and set that equal to the x equation. And then, of course, if we add 3t to both sides and then divide both sides by 3, we get that t equals 2. That would be the time that the object on this equation would be at the y-intercept. And then number 3 follows that up and says, well, now that we know that the time is 2, what is the y-intercept when the time is 2? And that really should be pretty easy, because all we're going to do is take the 2 and plug it back into the y equation for t. So the y-intercept is when t equals 2. So we'll plug 2 in for t there, and we get 0. So the x-coordinate was 0 and the y-coordinate was 0, so this is actually at the origin. Alright, hopefully haven't lost anybody yet, and that makes sense. So now we want to know what the rectangular equation that models this movement of the object above is. So the rectangular equation is the equation just like you would normally see it as a y equals mx plus b. And we have several different ways that we could go about doing this. We have the x and y value here of the y-intercept. We have the slope. Well, if you have the y-intercept and you have the slope-intercept form, y equals mx plus b seems to be the easiest one to do. So in this case it would be y equals the slope times x plus b, which is 0, which you don't have to write. So that would be the rectangular equation that models the movement of this object. This is your y equals mx plus b. Now the question is, would the object be moving to the left or to the right? So are we either going to go left to right or right to left? Kind of an interesting question. In parametrics, the direction is actually dependent upon which direction the x's and y's are going. Well, we got to go back up to number 1 and look at number 1 and say, okay, the y value, which is the numerator, was moving in the positive direction. That's going up and down. So that would actually be moving up. It's the x direction that determines whether this thing is moving left or right. And the x direction from up here was -3, which indicates that the motion of the particle is actually moving to the left because it's a negative x direction. So this is going from the right to the left. And I can kind of illustrate this. Let's see if we can change things up here a little bit. So here's your standard XY plane. And let's see. If we go with time t equals 0, that's going to be off my graph. So t equals 0 will be the 0.6 negative 8 if you plug 0 in up into these equations up here. So let's count every one of these hash marks down here by 2's. Let's call these 2's. So let's see if this works. So 6, -8. So 2, 4, 6, -8 is right here. That's at time t equals 0. And then if we go to t equals 1, if I plug a 1 into each one of those things here, let's see, the x value is -3 times 1, so that's -3 plus 6 is 3. If I plug a 1 in for y, that's going to be 4 minus 8, which is -4. So x equals 3 is going to be in between the first and second hash mark, and then down -4. Here is my second point. Now we know we only need 2 points to make a line, but what you can see is that at time t equals 1, this thing does move from right to left. It's actually moving in that direction. Now linear function does go on forever in every direction, but it's important with a parametric to indicate the direction, so we put little arrows showing the direction of motion based upon the t value, which is the independent variable. So that's kind of what's going on there. And then where is the object at time t equals 10? Well, again, that's just literally plugging 10 into the equation. So for x at time t equals 10, it's -3 times 10 plus 6. What is it? -30 plus 6, so -24 for x. And then for y, it's 4 times 10 minus 8, so that's 40 minus 8, which is 32. So at time t equals 10, the object is at -24, 32. That is your ordered pair. And that's way to the left of where we had our little graph here. All right. So now let's take a look at number 7, which is the last question on the page. It's given these two objects, and the two objects have parametrics. This is very much like the homework. We're trying to see if these two objects collide, and if so, where and what time do they collide. Well, the easiest thing for us to do to first look at is, are the two objects going to at least cross paths? Even if they don't hit at the same time, are they going to cross paths? And the answer to that is really simple. If you look at the slope of object number 1 and you look at the slope of object number 2, the slope of object number 1 is going to be -1 over -5, which is really 1/5. The slope of object number 2 is 8 over 3. It's the change of y over the change of x, which is 8/3. Any two linear functions that have a different slope, the paths will cross. The lines will intersect somewhere. Okay, that's a given. The question is, are they going to intersect at the same time? Well, probably the easiest way to do this is to set the two x functions equal to each other to find out what time the x's are the same. and then to take that time and plug it into the y and see if you get exactly the same thing. So let's see if that works. So we'll take negative 5t plus 2, that's the x for the first object, and set it equal to 3t minus 14. Solving for t, let's add 5t to both sides, and then add 14 to both sides. What did I do wrong? Oh my gosh. I tried adding 5t and somehow got 5t. That should be 8t. I was like, that doesn't work out right. Okay, there we go. That's much better. Alright, so t in this case is 2. So now if I plug t equals 2 into both of the y equations and get exactly the same y value, I know that they will collide or hit at exactly the same time. So let's plug t equals 2 into the first one. So that would be y equals negative 2 plus 13, which is 11. And in the second one, y equals 8 times 2 minus 5, which is 16 minus 5, which is also 11. They hit at exactly the same time. So it says, where do they collide? Well, they collide when t is 2, so we know that y is 11, and when t is 2, x is, I believe it's negative 8. Yeah, we have to plug 2 back into one of the x equations, and I believe you get negative 8. So they collide at negative 8, 11. Okay, that is the where, and the what time was t equals 2. There are multiple different ways that you could get that solution. That's probably the easiest one in this case to be able to do that. And again, hopefully that kind of rings a bell from what you guys did in the homework. Alright, we are going to come back with one more video, and that will be the last one for the day.